Hello and welcome to the BMC Quick Course series. My name is Lucinda Breitenbach and I'm a software consultant for the IMS products based in Houston, Texas. In this demo, I'll show you how to partition IMS databases using BMC Partitioned Database Facility or PDF. Before beginning your conversion, decide how many partitions you need and determine how you want your partitions populated with database records. Do you want to spread the records evenly across partitions, or do you want to assign key ranges to specific partitions? When converting a database to PDF, replace the dataset statement with PDF part statements using one part statement for each partition. If you're using a partition selection routine, add a part DBD statement, and if you're using dataset groups, add dataset statements representing group 2 through 10. Now let's take a look at how to change the DBD for specific database types. In these examples, I will omit the DBD gen, finish, and end statements. To convert a HIGHKEY database to partitioned HIGHKEY, replace the dataset statement with part statements. Insert the part statements immediately after the DBD statement. Each part statement refers to a partition in the database. The values within each part statement refer to the DD name of the database dataset and the high key of that particular partition. The highest key for each partition is defined, thus giving a key range for each partition. Please note that the high key ends in high values, and the high key will not be accessible to application programs. PDF will insert records into each partition depending on the high key value of the partition. The high key of the last partition will, in all cases, contain high values and must not be coded. To convert an HDAM database to partitioned HDAM, add a part statement for each new partition. The part statements replace the dataset statement. Notice that size and root are specified in the part statement, not in RM name in the DBD statement. Because a single-stage randomizer randomizes across the entire database, do not use it for a partitioned HDAM database. Either use a two-stage randomizer or use a partition selection routine with your single-stage randomizer. With PDF, you can use the same randomizing routine for both non-partitioned and partitioned HDAM databases. Non-partitioned HDAM randomizers spread the root addressable areas and the HDAM overflow across the entire database. With partitioned HDAM, each partition has its own overflow area at the end of the root addressable area and is used for segments that cannot be stored in the root addressable area of that partition. The number of blocks in the root addressable area and the CI block size can be different in each partition. However, the randomizing routine and the number of wraps per block must be the same for all partitions. As an alternative to a two-stage randomizer, you can use a partition selection routine to select one or more partitions. Over time, you may need to add or remove partitions. If you don't use a partition selection routine, or if you don't use a two-stage randomizer, you unload all records in your database, sort them, and reload them, which can cause a significant outage. A partition selection routine might be convenient because any part of the key can be used to determine the partition. The partition selection routine is called before the HDAM randomizer to randomize to a block and wrap number within each partition. The number of blocks passed to the randomizer is the number of root addressable area blocks in the partition selected. A partition selection routine enables you to identify a partition within the database for a record, and then your normal randomizer can specify the placement within that partition. In effect, a partition selection routine mimics the first stage of a two-stage randomizer. To add a partition selection routine, add a part DBD statement and specify the name of the routine. An alternative to both the two-stage randomizer and partition selection routine is to use HIGHKEYs with HDAM to establish key ranges. If using key ranges is sufficient, HIGHKEYs may offer a better method to provide a two-stage partition selection process. After PDF selects a partition based on the HIGHKEY, the randomizer is called to randomize within the partition. As with the partition selection routine, the number of blocks passed to the randomizer is the number of root addressable area blocks in the partition selected. A database with dataset groups is converted to PDF by adding part statements and dataset statements. This example shows a partition HDAM database with two dataset groups. The first dataset group is identified by the part statements. Part statements represent partitions as well as dataset group 1. Dataset groups 2 through 10 are identified by dataset statements. In this example, each partition consists of two datasets. With two partitions, the database contains 4 datasets. Index DBDs are converted in the same manner as HIGHDAM DBDs. Insert part statements after the DBD statement and specify the HIGHKEY values for each partition. When a database to be converted is in a logical relationship, you do not need to convert all of the databases in that relationship to PDF. The database must use symbolic pointers. The main issue with logically related databases occurs when the logical children are virtually paired rather than physically paired. A SEGEM statement with a source parameter will identify virtual pairing. This must be converted to physical pairing before partitioning. Consider using a product such as BMC Restructure for IMS to convert the virtual pairing to physical pairing and convert to PDF in one execution. Thank you for your time. For more information about any BMC mainframe product, please visit the URL shown here.